Well, while he's pulling that up, I'm going to go ahead and get started. This is an interesting series for me because I worked for 31 years with Shell and as a geophysicist and drilled a lot of oil wells, and using principles. I was taught the secular millions of years principles, and I didn't believe that. I believe, as a Christian, and believe that God created things in a young earth. But I didn't know how to apply creationist principles into study, search for oil and gas. And so I got laid off in 2021. And one of the things I wanted to do was get into creation science, precisely for the purpose of saying, how can I use this, which I believe is the correct way things were laid down, the rocks were laid down, in order to better find oil and gas. And so one of the first things I did when I searched, I found hydroplate theory presentations, and I went through it, and it's very interesting and certainly biblically based. But I didn't really find ways I could use that practically as a geophysicist. And then I went to the symposium that Frank is talking about here at GHCA with John Baumgartner and Tim Clary, talking about catastrophic plate tectonics, and Tim Clary, how he's using all the oil well data from the industry. He worked in the industry in the past, and has mapped out all the layers and how they are extensive and all of that, and using all the techniques that I've used as well. And then in those theories, I saw ways that I could use this, and it did a lot of the things that I see on seismic and wells better than in secular millions of years theories. So yeah.
Are you going to cover that?
Yeah. Yeah. So what I did, catastrophic plate tectonics was come up with by John Baumgartner, and he's a PhD, very brilliant guy, and to present that, I wanted his slides, and that's what I asked him for, and he was happy to share that. So I'm going to be presenting his slides with a few of my own added. And yeah, now I'm working again in the industry, and I'm actually using these principles and understanding better the early formation of the Gulf of Mexico. I've worked my whole career in the Gulf of Mexico, and the earliest rocks that were laid down, which is all explained by catastrophic plate tectonics. So I'll show you some of that.
Does your current employer support your theory in using that information?
No, I haven't asked. I don't know. But I actually have a talk the end of this month at the Image Conference, which is a conference of Society of Geophysicists and AAPG, the Society of Geologists, combined talk. And it's talking about the how I think we can identify source rocks on seismic. And I don't know if I would have come up with that paper, and I did use this type of information for that paper, even though I'm not explicitly, if they ask about it, I will mention it. But I'm integrating this work, but I haven't really asked for permission to do that, I guess. Okay. Put this on full screen. Okay. All right. So this is John Butler's slides. The first thing he wanted says, what sort of images come to your mind when you hear Noah's flood? And for many Christians, it's, the rains came down, the floods came up. It hasn't advanced a lot since Sunday school. So, Oh, that's, so I swapped it. I shouldn't have done that. Sorry. It's relying on to go back and swap again. I swapped the presenter view. And I messed things up for that. Okay. Here we go. Okay. So just going through Genesis here, the God saw there was the wickedness of man was great on the earth, and he said, I'm going to wipe out the earth and all that I've created. But Noah found favor as a righteous man. And then 600 years of Noah's life, the rain began falling for 40 days and 40 nights. And the water came up so much that all the high mountains everywhere were covered, all flesh on the earth perished, and all of man. And the water was on the earth for 150 days. So there is a good bit of information in the Bible about the aspects of the flood. So if there was this great flood, it would have been the end of the world for however many humans were alive at that time, minus the 8 that were on the ark. And so a total destruction of all land-dwelling, air-breathing life on the earth would have left an abundance of physical evidence. And what sort of evidence might we expect? So we'd expect to see billions of dead things buried in rock layers, laid down by water all over the earth. And that's what we see, all the fossils, so many fossils in all the rock layers, and fossils everywhere, even up on high mountains, have sea creatures and things that lived in the waters and were, so there's evidence for that. What about the rock layers themselves? What sort of physical features should they display if there was a global flood? And there's a lot of evidence for that as well. So here's a picture of the Grand Canyon, and this shows kind of what the earth is like, not only on land, but under the water too. You have all these layers, extensive layers, and these layers document a global flood in an overwhelming and undeniable way. Well, let me keep going. So all of these layers consist of things like sand, silt, clay, carbonates that have been suspended, transported, and deposited by moving water. And so you have these laterally extensive layers. And then, they can continue horizontally for hundreds and even thousands of miles in all directions, which implies water processes responsible that were really large in scale. And then the fossilization starts. There's no fossils in the Precambrian, or very limited. But then all of a sudden at this, I don't know if you can see my pointer. No, let me turn that on. At this level, called the Great Unconformity, all of a sudden above there, you start seeing abundance of fossils. And that's known as the Cambrian explosion. And then the sequence of layers, commonly the boundaries between them are flat with little evidence of erosion or channeling across the layer boundaries. And one we're going to look at carefully is this one here between the Coconino Sandstone and the Hermit Shale. So here's a picture of it from the Bright Angel Trail. It's a popular trail at south rim of the Grand Canyon. But it's just very flat, no evidence of erosion, weathering, and it continues like that for a long ways. Implications of this is that if you've got such uniform, extensive for hundreds of miles layers with flat boundaries, requires that vast portions of the continent were flooded by rapidly moving water and were nearly smooth. Had to be high water speed to keep So it's suspending all of these sediment particles, carrying it up well onto the continents and keeping it suspended. And these are turbidites, we understand that quite well. So they had to have high water speed to keep those particles from dropping out and being deposited. So it implies a regime of erosion, transport, and deposition that's different in the past than what we see today. Today, you see things like this. The more towards surface level of the continent are sculpted by erosional channels. Sedimentation is generally limited in extent. And you see the layering is oftentimes destroyed or disrupted by burrowing organisms. And different canyons, these are different national parks because of the spectacularness of the canyons, things like Bryce Canyon, Zion, Grand Canyon. This is dramatic, hundreds of feet of erosion or more, thousands even. And sure.
Do we know what burrowing organisms they were? Do we know what they were?
Lots of different organisms burrow. Sometimes you do see fossils and stuff to know what they are. This is talking about in modern times. Yeah, it's beetles, lots of worms, lots of different things like that. It could be bigger, I don't know. But what we see in modern processes is layers get disturbed by these kind of things. Yeah. But these giant canyons like this, we don't see, we don't see it deeper than the Great Unconformity. And there's abundant physical evidence that they had a very fast water velocities to be able to deposit these thick layers that are very laterally extensive. Some cases, underwater sand dunes 50 to 100 feet in height, or even can be significantly more than that. So one of those sandstones is the Navajo sandstone, very thick, displays giant crossbeds, which is an indicator of high-speed water flow.
Oh, that's a...
Yeah. So this is an example of the Navajo sandstone with crossbeds. And these fine layers is indicators of high-speed water flow, these crossbeds where you get the changes in direction.
That's when the net tilts and goes water, goes for water.
Well, there's been research on that, and for example, in the Coconino.
Based on what I'm telling you, based on research.
Okay, but based on the Coconino sandstone, the angles on them that had to be laid by water, not that wouldn't windblown has lower angles. Laboratory experiments show that the water laying sandstone, well, I think it has higher angles than aeolian. Yeah, I know the old
20 degrees, 25 degrees. That's a windblown deposit.
Well, what sandstone I've worked with is the Norphlet, which is buried underneath the Gulf of Mexico, and the common understanding was that that was aeolian as well. It didn't make a lot of sense. You have aeolian is laid down in a desert environment, windblown, and then right on top of it you have the Smackover, which is water laying and even deep water. How could that happen? One of the things that didn't make sense from
Coconino is Permian. That's back when.
Okay, well, I don't know as much about the Coconino, but I know about the Norphlet, so I'm trying to explain. And our common understanding was that these were sand dunes, windblown. But then when we sent detailed rock samples to be analyzed for environment of deposition, without telling them where it's from, so a fair thing, look at the rock, what do you think? What came back was these are water laying, and so it changed our idea of
That's
that.
not what they're showing you.
Okay, well, Yeah, there's been a lot of good research in the Coconino that shows that most likely it had to be water lane. Well, there's a lot of papers. Yeah. No, this is research. You take the research and things can change. That was the old view. I think there's a lot of good new views.
Conventional geologists all know. The only people that don't believe that are the younger.
Okay, well, I'll show some more evidence. Just listen.
You can talk next one.
Yeah. I knew I was going to get that kind of response.
Well, don't be rude to the guy, come on.
I'm just pointing out where he's getting incorrect information.
Well, maybe it isn't that anything yet.
It's not.
Well, I'd be happy to send you the latest research on the Coconino. In fact, I think it's on the GHCA website. Okay, well, I tend to believe that evidence. I've looked at it. Anyway, because fossils and require rapid and complete burial, it's a reliable indicator of catastrophic conditions, including high water speed. One of the interesting things, I was just at the Houston Museum of Natural Science a week or two ago, and they have a poster about fossils, and they also admit that because it requires rapid and complete burial, that even the secular community acknowledges that most fossils had to be created with floods. And I took a picture of it. Fortunately, I didn't have it to share today, but you can see that in HM&S. They acknowledge that almost all fossils were laid down by floods. So these processes for these features in the fossil-bearing sediment record, are they happening today? The answer is no. So one of the key principles of uniformitarianism is that the present is key to the past, but nothing that we see in the present can explain the rocks, the fossils. So it requires a rethinking of the current understanding. And I think that's one of the things I really strive for. If we can have a different mindset, there's been a lot of exploring with this mindset, but what happens if you explore with a different mindset? I think you might find more success. So the only place within the biblical account that would allow such laterally extensive fossil-bearing sediment layers that could have occurred is during the Genesis flood. And the text reveals that all this activity unfolded within just 1 year. And so I wanted to kind of tie in one of my own, this is one of my own slides. So I was, so when I saw this, I realized that almost all fossils were laid down in the flood, which makes fossil fuels are actually flood fuels. And, as an explorer working in the energy industry, I was very proud to do that because, you provide, the more oil we find, the cheaper it is for people to be able to do things like fill up their car, heat their home, electricity, all of that. And if we find it here in the US, then we're not supporting terrorism or things like that. But this made me realize the purpose for all of this. These things were laid down by God. And so, we think about at the Garden of Eden in the fall, when humans were banished from paradise and then subject to death, God provided the answer to that, that's mentioned in Genesis 3 about how there will be a future descendant of Adam that will crush the serpent's head. And so even with judgment, there was the provided promise. And I kind of see the same thing in this. So God told man to be fruitful and multiply, fill the earth, multiply on it. But then the flood, he's wiping out almost all of mankind, but 8 people. So how are we going to be able to fulfill that mandate? Well, even in the destruction, of the flood, he provided all this fossils and organic material that got laid down, got buried deeply, and in order for it to form into oil, gas, coal, things that are required, to have 8 billion people on the earth, you couldn't do that without all these fossil fuels. And these are some plots that show that. So these are plots showing population in green, life expectancy, GDP per capita, so how much standard of living basically, and then carbon dioxide. So as we're using energy, this is saying you couldn't sustain this amount of population, all these good things, longer life expectancy, higher incomes without fossil fuels. And this is just the same thing, but going back, this goes back to 1760, this goes back all the way to AD 0, showing the same thing. So they're very connected. And this is another study showing how energy use is what stamps out poverty. So these are all countries. The countries that use more countries that use more energy have lower poverty. Countries that use less energy have much higher poverty. So the key to moving out of poverty is actually energy use. Fossil fuels, the richest countries generally are the ones with most natural resources. So I just see, God wants all of man to be able to hear of the gospel, the good news. And you could not support all the people on the earth today without fossil fuels. He wants them all to be able to live so that they can hear the message. And there's currently, modern technology, ways to reach all these people with the good news in advanced ways. Things like The Chosen is being transmitted into many, many different languages so people can see about Jesus's life, Jesus film. There's lots of ways. So I feel a real passion, real good about working in the energy industry because it's just such a benefit to be able to keep people out of poverty and be able to support the number of the on the earth today. And it's just, if you think about environmentalists, they are, I'm looking at this Romans 1 passage here, they're worshiping the earth, saying we can't have so many people because the earth can't support it. We have to take care of the earth, and who cares what happens to people, but they're worshiping the earth rather than the creator of that earth. So yeah, this realizing that all the fossils, therefore all the fossil fuels were laid down by the flood, really, I thought that was pretty cool. One of the things that came out of that, learning about catastrophic plate tectonics. So what caused this? How could so much change occur in such a brief span of time? And this was really spurred by John Baumgartner once we found some interesting information about the ocean floor. So in the 60s, it was revealed that all of the oceanic crust that we see today has been formed recently in Earth's history. All of it is younger than much of the continental fossil-bearing sediment record. And so here's the point. Basically, it's Jurassic and younger in the secular time scale. All of the oceanic crust is of that age. That means that all of today's ocean crust has formed after the onset of the flood, which I believe is represented by the great unconformity, deeper than that. So this implies the entire seafloor spreading. Both secular and creation scientists believe that at one point the continents were all together, and that's even biblical, talking about how the waters were gathered in one place and the land in another place. But the fact that that ocean crust is young indicates all of this seafloor spreading happened in a few months' time in the flood.
Radiometric dating has 180 million years.
Yeah, there's other evidences like C14 that can't survive more than 100,000 years. What about soft tissue and dinosaurs? So there's counter evidence.
Oceanic crust dates at 180 million years,
Mm.
right there across North America on the East Coast.
Well, if you believe,
right there in the center with it,
if you believe that the Jurassic is 180 million years old, but there's not. Anyway, we'll show. There's more. Let me finish the presentation. If you believe the Jurassic is 180 million years old, yes, but it doesn't have to be. There's a lot of evidence that says it's much younger than that. Yes, there is. But anyway, let me finish. So the pre-flood, what happened to the ocean floor that was there pre-flood? It's entirely missing from the Earth's surfaces today. And we believe that it's almost certainly recycled into the Earth's interior during the flood. And that is not just creation scientists. I'll show a Science Digest recent article that says that secular scientists have kind of come to the same conclusion. So these observations led to the conclusion that large-scale tectonic change must have been a fundamental aspect of the flood, which has led to understanding known as catastrophic plate tectonics. And John Baumgartner originally presented this at the International Conference on Creationism in 1986. So large-scale tectonic changes at the Earth's surface requires that the Earth's interior also had to be involved. So let's look at the Earth's internal structure. So this is the cross-section of the Earth. You've got mostly solid rock on top, and the core, which is mostly molten iron. So the strongest thin cold part is the lithosphere. This is where the plates form, and broken up into several large plates. And then below that, you got the asthenosphere, which is weaker, allowing these plates to move freely over it. And what happens then, as these plates are pulling apart in both directions, it runs into other plates, and what happens is the oceanic crust, being cooler and denser, subducts below the continental crusts, because its lower temperature makes it more dense. So it sinks down into the Earth. And so as those plates, are moving apart in both directions, you're creating an opening. And so then into that opening is going to come the magma, and it's going to flow out onto the ocean and cool and form new oceanic crust. This is molten basalt that rises into that gap. So catastrophic plate tectonics is similar to conventional plate tectonics. They also believe that these things moved apart and the same processes, but it's just much, much faster, 5 miles per hour instead of 2 inches per year, because currently the crusts are moving about 2 inches a year or so, or less. And so they believe the present is the key to the past. It must have always moved at that speed. And so then it takes millions, hundreds of millions of years to do that. But could it move faster? And from laboratory experiments, we know that mantle rock weakens dramatically under stress levels that can exist inside the Earth. And so as the stress causes the mantle to weaken, then it's just going to create a chain reaction that's going to move these processes faster and faster and reach these very high speeds.
Isn't the mantle denser? The crust speed, the velocity speed is faster than the mantle, at least the lithosphere, where it gets very faster.
Okay. So how much continental motion occurred during the flood? And we've got some images. This is from Professor Blakely of Northern Arizona, just showing, and these are common in industry, but so going back, this is Pangea when believed all the continents were together, one landmass, and then stepping through time, you're going to see the continents start to pull apart. So you can start seeing South America, Africa. Some things are still pretty unrecognizable at that stage. Now you can see, here's South America, here's Africa, North America. It just keeps pulling apart. You got these seafloor ridges coming up here, and things are moving apart. Now you see the separation of Africa, South America. Here's Antarctica, Australia, still connected to Antarctica. India, this will become India, is starting to move. And keep going, it gets more like we see today, but India has not yet collided with Asia. And so then at this point, it has. And what happens when you've got such speeds of plates coming together is you get thrusting up of the continental block, and this is where mountains form when plates come together. So you'll see where India hits Asia, you form the Himalayas. So this also explains, mountain formation, and as North American plate, Pacific plate come together, you get mountains along the Rockies and the Andes. So all of that movement, we believe, occurred during the flood.
What about the Appalachians?
Appalachians was from an earlier, when also a collision of continents. I think it was Africa came together with North America. They bumped together.
So you do believe they were separated and then came together?
Yeah.
The starting point is not Pangea.
Right. Yeah, it's pretty much the same belief with the secular community. It's just the speed of the movement. Okay, I have to get through a lot of slides. I can't just answer your questions. So John Baumgartner also has done this kind of thing. So this is a snippet of a paper he presented with Navarro in 2023. And this is where I'm incorporating the work. So this is a time of the late Jurassic, which is, I'm studying the Tithonian source rock, which is in the Gulf of Mexico. And so I'm using the catastrophic plate tectonics model that John Baumgartner developed. And what you see here, all these things are tsunamis. When you have plates moving that fast, it's going to create tsunami waves. And one of the great things that, I'll show this coming up, but John Baumgartner has created a whole Earth model with this. And so he brings apart the continents, and then the result of that, at those speeds, it forms tsunamis. These tsunamis then erode as they hit the land, and the second slide is showing the erosion, and the third is the deposition, and it deposits that more on the interior of the continents. So seeing things like this helped me understand how things like the Tithonian source rock got laid down in the Gulf of Mexico, because it's going to tear the organic material off of the coast and deposit it. So this is how I'm incorporating this into my work today. So that sequence that was shown is within the time span of the fossil-bearing sediments. So all the plate motion, again, must have been a few months' time. So catastrophic plate tectonics, just like conventional plate tectonics, accounts for mid-ocean ridges, deep ocean trenches, volcanism. We know with subduction that you often have volcanism adjacent to the trenches, and earthquakes. But some processes are distinctive to catastrophic plate tectonics, such as the supersonic steam jets, and this actually is a similarity with the hydroplate theory, is kind of similar mechanism. But when you think about all of this magma rising up very hot, hitting the seafloor, what's going to happen? This is very rapidly going to flash to steam, and then all this water is going to go up into the atmosphere and come down as rain. So, even rain for 40 days and 40 nights can't cover the whole Earth, but this process, and then the additional process, when this new seafloor is created, you're raising the levels. It's hot, it's buoyant, it's raising the levels of the oceans, and it's causing all that water to flood over the continents. And then the tsunami processes will also help to get the water over all the continents. So the question is, how can an ocean plate sink vertically through all that mantle rock in a few weeks' time? Because the mantle rock weakens under stress. So this is the sinking oceanic crust that's dense. So there's been research on mantle materials, how they deform. These are some electron microscopes images showing how mantle elements deform, and so it's got shear stress, and like cards, they slide past each other. So this is deformation rates for mantle minerals are known. And so you can put in all these parameters and run models. And this is a 2D model that shows, here you got the cold original crust, and you have hot magma coming up over here. These things are sliding, and this is subducting, and then the crust goes down, and until it reaches the bottom. And there it's just in an animation. And in the meantime, you've got the magma coming up over here. So that's just a 2D simulation, just showing the physics works. As the stress weakens the rocks, it can produce catastrophic consequences. And then John has built a 3D model of the whole Earth, and it's using correct physics and solves balance of forces. And I can't go into all the temperature, all the equations, but so this is his starting point. And we know where these subduction zones are. And so he starts calculating with the continents in this configuration and these existing subduction zones. And this program starts, this is a temperature slice of the Earth. So here's the cool temperature in blue as the ocean crust starts dropping.
Sir, could you back up
Sure.
to two slides before this one? And this is two, no. Yeah, I just can't.
Yeah, I know it's a lot of material. I have a lot to cover. It's hard. But this is before we were seeing all the continents together. You have North America, South America, Africa. So this is showing the starting point of the 3D model, the whole Earth model, where they're all together. And then you'll see animations as these things will separate. This is the temperature. So this is where the cooler rock is sinking into the Earth. And you'll see that change as these things get going. So here it is again. So the blue zones are where the oceanic crusts are coming, sinking, subducting down. These are the mid-ocean ridges. This is where new seafloor is being created as the magma is coming up and spreading out. And so that's very hot. And the cooler rock is sinking below the continents, subducting below the continents. So that's where the old crust went. And then this is the new crust, is with the hot colors.
What initiated all this?
Well, that could have been God to start the flood. Basically, this model shows how the floodwaters could cover the whole earth, and so that may have been something that, believe it, from the record, it appears to be the method in which God caused the flood to cover the whole earth.
We do acknowledge that initially you had Pangea and then you had continental crust rippling. You acknowledge that, don't you?
Well, I've got a lot to cover. I can't answer all questions in the middle. Let's hold those to the end. So here's another simulation showing the cold. This is now the 3D model, showing the cold material dropping other places, the hot material going up. And now you're looking at different slices. So here's Greenland. But basically, this is all slices from a 3D model that John created that simulates or models how all this happened. And secular community has nothing like this that can explain sedimentation all over the globe like this model does. The sedimentation patterns, I think I can get into that later, but that this model produces matches what we see from wells, from seismic, from field observations, suggesting that maybe this is an accurate model. So here's a different view. But what you always see is the blue, the low temperature stuff is under the continents. And so there are ways with geophysics, studying seismic waves, that we know that there has to be some cold material under the continents, or the seismic waves that we see from earthquakes and things wouldn't make sense without that cold material there. So there's evidence that this indeed happened. And so that's probably what it's coming to right now. Yeah, so seismic images of the mantle reveal a ring of unexpectedly cold rock at the bottom of the mantle beneath the subduction zones that surround the Pacific Ocean. Now, if this was secular community, they believe this happened over millions of years, that cold seafloor would not still be cold now. Over millions of years, it would heat it up as it went down into the hot earth.
It's very cold and dense, don't stay that way.
For hundreds of millions of years?
Not all of them do, but some of them do.
No, I don't think so.
What's your textbook? You have the name on it?
I go all over the place. My field is geophysics. I do what this guy does.
Yeah, no,
My
give us
background is in
give us
geology.
your reference so we can check it. You maybe will stop interrupting.
And
What's your reference?
And I'm going to show.
What's your textbook?
I'm going to show from a recent article.
I'm more up to date with that.
I'm going to show evidence just about a month ago, an article where in a secular publication, they say there's these unexpectedly slow velocity zones as most likely oceanic crust.
Your question. I get my stuff all the time. Well, you're asking me questions. Okay.
Yeah, you're disturbing everyone else that's trying to present.
I'm asking questions.
No, you're interrupting.
That is not the way we want to operate.
Okay, I've got to keep going. We can't take any more questions.
Sorry, Nathan, go ahead.
Yep.
If you don't like what you hear, you're welcome to leave.
I'm here to ask questions.
Well, there's going to be more opportunity,
Questions will be taken at the end.
and there'll be more opportunity for that next month as well. Okay, so this is a seismic tomography image. Blue says low temperature and red's high temperature, differences of 3,000 degrees C. So they have huge temperature differences. I don't think that would stay that way over hundreds of millions of years. That violates the laws of thermodynamics. But what we do see is these cold areas ringing the Pacific. And the temperature of that blue ring of rock is nearly the same as rock that's near the Earth's surface. So that says it had to have happened fairly recently for that to still be near the same temperature. So powerful evidence for runaway subduction. Yeah, and so this from Science Alert. This just happened, this was just published a month or two ago, and it's showing very much the same thing. Here's the cold rock coming down, hot rock going up. And they mention these in orange, ultra low velocity zones. And so look here, these ultra low velocity zones are most likely oceanic crust buried over millions of years. Well, they wouldn't still be ultra low velocity if it was millions of years. But even the secular community is acknowledging these same physical processes that that John Baumgartner has in his model. So what is the energy driving this process? It's the gravitational potential energy associated with initial temperature differences. It's just gravity driven because the colder rock is denser than the hot rock. So further questions: how were the continents flooded? What caused the waters to drain away? How was this huge volume of fossil-bearing sediment deposited? So as that cold, higher density ocean plate got replaced with a hotter, less dense ocean plate, that's gonna, the hotter, as I explained, plate is buoyant. It's gonna cause the ocean floor to rise, the volume of the ocean basins decrease, so the water spills out onto the continents. Okay, and then after 150 days, God caused the newly generated ocean plate to cool. I mean, it will naturally cool coming into contact with waters as well, but there seemed to be some dramatic cooling that happened. Maybe that was caused by God to enable the ocean floor to subside, and without that, there was no places for the waters to go. But as the ocean floor subsided, then the global sea level fell by 1,500 feet, and suddenly all that water up on the continents could drain back into the oceans. And when that happened, huge volumes of sediment were stripped away from the ocean, creating these huge canyons, Grand Canyon and others. Here's a view of Bryce Canyon, and obviously huge erosional testament that there was huge volumes of water to create these giant canyons. Here's arches. You see all these smooth things. Recently read an article on Creation Ministries International talking about how there's one arch per day per year that collapses in Arches National Park, and they have about 400, and they play that out, and there's no way that these things could be millions of years old, because there wouldn't be arches left at that point, that even though they're formed in rock that's supposedly close to hundreds of millions of years old. So more evidence for a young Earth. So just to answer for how all the sediment got deposited is tens of thousands of tsunamis, very large tsunamis, and they're produced by, as this plate's subducting, it locks up with the other plate and then it unlocks. And so what happens once those seafloors dropped, then all that sediment that was suspended, some of it gets deposited on the continent, some of it gets pulled into the continental shelves. And so these purple and red colors showing the thickness of sediment. The Gulf of Mexico, where I work, shows very thick sediment. So a lot of the water that was on the North American continent got drained into the Gulf of Mexico and deposited on the shelves. There's more up on the north slope of Alaska here. Mediterranean, very thick. So in these shallower shelf areas is where a lot of the sediment got deposited, which is a result of runoff in the final stages of the flood. And these areas, Caspian Sea, tend to be areas of very good oil exploration. You know, I'm just struck by the way this map of sediment thickness matches with big areas in oil exploration, because, you know, this is sediment material that can contain organic material for the source for oil, as well as the reservoirs where they end up in. So you have to have an explanation for how in a few months' time such a huge volume of sediment came to blanket the continents in an orderly way, and it is, we believe, John believes, and I believe, that this is tsunamis that are causing that. So in March 2011, there was a magnitude 9 earthquake, huge, very powerful earthquake ever recorded in Japan, and that's caused 160 feet of slip between the plate, which Japan is a part of, and the Pacific plate. And so the sea bottom, as that unlocked, it snapped back, rose about 23 feet, and that triggered this devastating tsunami. And here's a picture of it coming in over a seawall. A little bit later, it's moving inland. So you can imagine the tsunamis, it's going to erode stuff here, and it's going to carry that sediment. You can see some of it coming in here further onto the continent. Damage reached as much as 6 miles inland and 133 feet above sea level. Just total destruction, lots of people died. So tsunamis are generated in subduction zones, where the two plates are locked and then they slip. And when it slips, the overriding plate springs back into its unstressed shape. So this is, these two plates tend to lock along this fault. And so they're locking. This is continuing to try to move. This gets pulled down, creating a little trench here. Then suddenly this part releases, it snaps back. That causes the water to snap up, and then it goes out in both directions. Another discovery is this phenomenon of guyouts, or table mounts. These are volcanic seamounts that's just been beveled flat because of wave action, and believe that only thing that could have caused it would have been extreme tsunami activity to flatten all of these seamounts. There's approximately 50,000 of them. Most of them, many of them are flat topped, just in the Pacific Ocean, extinct volcanoes. 283 known ones in the world's oceans, many in the Pacific. Here's an example off the coast of Massachusetts, Flat Summit. This is 3,600 feet below sea level. How's that flattened by waves when it's that deep below the surface? Here's several examples from the Pacific. Contour maps, when the rapidly close contours, that's very steep. When there's not many contours along the top, that means it's flat. And these tops are mostly 12 to 1,600 feet below sea level. More examples, Coral Sea off of Australia. But this is a key point. They're dated to the Middle Miocene, which is near the end of the flood, near the end of the sediment record. So this is giving us some ideas from the Cambrian explosion and the great unconformity. We believe we know when the flood started. And from evidence like this, this would suggest that it was still active in the Miocene, which is near the end of the sediment record. So that gives evidence that the one piece of evidence on the end of the flood. So here's a schematic of it. This was originally a volcano that was higher, but it got truncated by waves that at the time would have had to be near this level. So that indicated that the ocean basins were much shallower. So the whole seafloor sunk. This top used to be close to surface, and the whole seafloor sunk as the new crust cooled. Again, during the Miocene age, and they're using the radioisotope ages here. That places the end of the flood in the Pliocene just before the Ice Age, which is believed to be the Pleistocene. So this is very recent. It again says most of the sediments were flood sediments. So here's Waimea Canyon and Kauai in Hawaii, known as the Grand Canyon of the Pacific. Deep, and this is solid basalt. What's going to carve that kind of basalt that deep? Huge tsunamis seem to be the only serious candidate. Ages of the basalt are Pliocene, so that's just before the Ice Age. So again, saying that the end of the flood was recent in geological time. So then John created the model. He called it Mabul. Mabul is the Hebrew word for deluge. He developed it when he was working at Los Alamos. Just some details on how this is created. But it seems the dominant means of sediment transportation is turbulent, rapidly flowing water. Open channel turbulent flow is applied, and this to treat the suspension, transport, and deposition of sediment. So this is a turbulent flow. It's going to grab a lot of the rock and pull it along until this flow slows. And it's only when the flow slows that the rock that's suspended in the water is allowed to drop out. And there has to be a method of erosion. So this whole model says that as these tsunamis come in, they're eroding the edges of the continents. It's getting caught up in the water, and it's carrying that further onto the continent. And it's believed that cavitation is the dominant process to erode the sediment as well as degrade the bedrock. So now you're going to see John's model. This is starting from this configuration where the green is the land and blue is the water. And then, yeah, so it showed the earlier time. If I went back, you were asking about the Appalachians. So there's a point in which they come together, and that we believe created some mountains like the Appalachians and the Urals that are
when did they come together?
Are rounded. You'll see it through the this as the thing runs, and then the fact that those are much more rounded, they had more erosion, whereas the Rockies, Andes, Himalayas, more recent, are going to be these sharp mountains. But see, they come together right there, and then they come apart again. And so this his model.
Where was everything?
This is explaining the flood. So I don't have time to get into all of that.
I'm trying to understand what your initial reference is.
No, it's starting from a point earlier than that.
So I was saying it wasn't Pangea, there was something different in Pangea?
It's not important. So this model is able to explain the sedimentation we see around the world, as I'll show. So clearly he's got it fairly right. Yeah, there's just not enough information that we can get on the real early history.
I'll just don't make things up.
That's, oh yes, we do. There's a lot of arm waving by geologists to explain things that are not easy to explain. I've heard a lot of it. What?
You said they make things up? The remarks you guys make, it's just
Anyway, keep going.
I have all kinds of information online, which I send to Frank over here, and he can verify.
Frank knows it.
Okay, so all these repetitive tsunamis generated by these rapidly moving plates subducting and unlocking and locking provide the forcing necessary to sustain these fast water speeds. So this is actually snapshots out of his model. This is at 65 days, so a little less than halfway through, and this is showing the water depth above the land. So the water is going to come, and first, just like that example from Japan, it went 6 miles in. The earlier tsunamis are going to travel some ways in, but not all the way. And so this is showing the sediment, the water depth above the land. So it's mostly high near the coast, but starting to spread a little farther. And then as you go, it's going to get farther and farther, spread farther and farther, because these tsunamis are being generated all the time as you're having the subduction and unlocking, and so gradually there is more and more erosion and deposition of sediment.
What's creating those subduction zones? That previous slide, is that supposed to be Pangea? I couldn't make out what exactly we're looking at.
This is at a point 74 days. So yeah, you have North America, South America, Africa, all, I don't know all the terms, but well, we explained that was along the whole continental crust as that was the cooler, the denser oceanic crust sliding beneath the
plate tectonics.
Yes.
Breaks it, right?
Yes.
Where's the plate tectonics taking place?
Well, I showed that in the earlier things. These are plots of the output.
All right, can you show all the different plates?
Anyway.
Would there be subduction?
It's over your head, so you can't explain it to us.
All right, you explain it.
So anyway, one of the things really cool that says, what makes a good model? A good model is one that can predict and match observations. Well, this is a model that matches observations. So here's the final output with the total cumulative deposition. So this is the sediment deposition. It's thicker in the reds and yellows. So on the western side, so all these tsunamis, this was all connected at the time. And so out of that snapshot that I showed out of the model earlier, the tsunamis are coming primarily from the Pacific. And so initially they're going to put the sediment here and gradually cover more of the Earth. But this sedimentation that's totally from the model matches what we actually see in the sediment in Earth. And Tim Clary, Institute for Creation Research, has done a lot of really good work taking in thousands and thousands of well data, geological data, and creating these maps of the different megasequences and sediment thicknesses. And he's, that his maps totally fit with John's model here, surprisingly good. And there's nothing in secular old Earth models that can explain this that can match this kind of matching observations. So look at South America. So these are showing where the shields are, exposed shields. That's the hard, old rock, which without much sediment deposited on top of it. Covered shields have some, and then the grays are going to be the thickest zone. So on the west side of North America, South America should have the thickest sediment. That's indeed what we see. Africa, you've got the shield covering much of the interior of it, where it's thinner. That's matched by John's model. So surprisingly good match with observations created indicate this is a pretty accurate model.
Are the shields ever submerged?
So these calculations reveal that tsunami, cavitation, erosion during flood can generate new sediment at a rate sufficient to account for a sizable fraction of the entire sediment inventory in the fossil-bearing part of the rock record. Water speeds were sufficient to sustain. You got to have really high level of turbulence to suspend all that sediment, carry it all the way up on the continents, and deposit it over vast areas. We know that there's huge layers that are cover much of the Western North America. That's only possible. That has to be laid down in one event. So you can't get that over current processes like that, seeing such huge, laterally extensive sediments, and accounts for the coherent patterns of. Okay. So, and this is what I was talking about, amazing correlation, the global pattern of sediment distribution, both thick sediment accumulation and regions of minimal accumulation that correspond to the shield areas. Okay. Yeah, I already talked about this earlier. Is this a repeat? And yes, so I showed one page of this paper that was presented at 2023 Institute, the Proceedings of International Conference on Creationism. And so, why is this issue of the flood and a solid defense of the flood being real so important today? Apostle Peter predicted denial of the reality of the flood would be one of the most effective deceptions of the last days. And indeed, a lot of young people say that because of being taught in schools and things about evolution, and that the biblical account is myth or fairy tale, that this is an effective deception that causes some people to go away from church. And so when we can demonstrate from science the proof, the reality of the Bible, that's a powerful weapon against that deception. So here's the Peter passage. All continues just as it was from the beginning of creation. That sounds like uniformitarianism that these people will say. Willfully ignorant that the earth was formed out of water and by water. The world at that time was destroyed, so the pre-flood world was totally changed. It got moved around. The mountains pre-flood were not as large. Otherwise, people would say, where's all the water that could have flooded the whole world to over 29,000 feet? Well, we believe that the pre-flood mountains were not as high, and they could have covered all of pre-flood mountains, and that amount of water is currently existing in the ocean basins at the time, which have sunk, creating more space for that water. So Peter's predicting that atheists who reject God will claim, because there have been no major interventions by God in the physical realm in the past, why would you expect that God's going to come back? But the flood is a powerful testament that he had judgment against the evil world at the time, and he's going to judge the world again the last days. And so all this flood evidence is things that shouldn't be ignored. So to deny that an event that actually happened is equal to denying that the Bible is God's inspired inerrant word, because the Bible is clear. Jesus said that the flood happened, talking about the days of Noah, Yeah, so that calls into question the authenticity of Jesus. Okay, yeah, here it was. Coming of the Son of Man will be just like the days of Noah. They did not understand until the flood came and took them away. And so shall the coming of the Son of Man, the second coming, it's going to be just as sudden and surprising. So the flood is a warning. And all these fossils, all these dead things laid down there is a warning for us that there's going to be a second judgment. So be prepared. Okay, that wraps up my slides, and I'd be happy to take questions. Do you want me to go back?
Somebody else asked a question.
Yeah, I got a question. Is it proper to call oil or gas a fossil fuel? Aren't there deposits way below organic matter?
Well, fossil can, yeah. I mean, there's fossils of plants. I think it is proper. But, a fossil is something that got rapidly buried, and so it preserves its.
No, I'm asking, was the oil there apart from an organic process?
No, I believe it came from the organic matter that got buried in the flood, and then subject to the pressures of all that sediment on top of it, and the heat as it got buried deeper, it converted into oil. And these are the processes that geoscientists study and model today. And then that oil will come out of the source rock layers and flow up to find lower pressures until they get trapped in reservoirs. And that's where we look for places to drill to poke into those traps and release the oil so we can get it to the surface.
So Nathan, how has all this helped you in your interpretation of seismic sections? Because seismic sections only go down to the very thin layer of the crust. And you're showing something more universal.
Yeah, I can go back a long way to talk about that. So I'm looking at, because we have this new data in my company that's sparse node OBN that's giving deeper images, better, deeper images than we ever had. It can give us clues about the earliest sediments laid down in the Gulf of Mexico. I should have to go way back. Yeah. So, this is showing, similar plots that are from CPT, but this is showing the beginning of the Gulf of Mexico, and this is the time of the Luan Salt, which is at the bottom, and that's also explained. I was interested in reading one of John's papers talking about when those jets, when this the magma comes up, interacts with the water gets converted to steam, the salt is going to be left. And so the first layer at the bottom of the Gulf of Mexico is this Luan salt, and it's very important for the oil. That salt gets buried by sediments. It's less dense, it comes to the top, it forms traps so that it traps the oil, and it's very important to understand that salt. So here's things like this can show where that salt would get deposited. And then this is the time frame for the Tithonian source rock, which is the key source rock in the Gulf of Mexico, for the deep water anyway. And so it's very laterally extensive. But yeah, I was going to this slide. So this is showing, these red areas here are showing all of the tsunamis that are generated. They're coming like this. And so here's the Gulf of Mexico just opening up. So one of the questions was, is the initial opening of the Gulf of Mexico open to the Pacific or the Atlantic? I believe from this work, it's more likely the Pacific, but a mechanism for that source rock is, as these tsunamis are coming in, it's going to take off all the plant life and things, and it's going to get deposited both in the just opening Gulf of Mexico as well as potentially farther up. But what I'm now seeing on the seismic is, I don't know how much I can show about all of that, but these kind of plots that show me the direction where those waves will be coming from, which that will then explain where the sediment's going to get dropped out at, are quite helpful in my interpreting the seismic.
What kind of mineral wealth is expected, like in Siberia and the Rocky Mountains? You said there was a lot of depositing in those areas.
Yeah, so I mean, we get a lot of the mines are in a lot of different minerals, copper, all sorts of them. I was really focusing more on oil and gas. There is a lot of oil and gas in Siberia. Yeah, I'm not so much of an expert on minerals, but just when we have big, thick sediment columns, that gives opportunities for both source rock and reservoir rock for oil and gas primarily.
Land salt is the evaporite formation.
Yep.
So, what were you saying before about coming from the deep?
Well, when when that magma comes up, you got the water. It gets flashed up to steam. The salt is going to be left, I believe, and so yeah, that water is being evaporated very rapidly as the magma comes up and encounters the seafloor. No, you had some ocean water coming in, just this little piece here, and then you've got these seafloor spreading centers. There's even some in the Gulf of Mexico, one in the Gulf of Mexico. As that new magma comes up, interacts with the water, it's going to evaporate it. It probably wasn't very deep yet, and so all it's going to be left is salt. I mean, that's a possible point about deposition of the land.
You're saying while it's still submerged, that salt existed?
No, the water is going to get, when you have still a shallow, just open Gulf of Mexico, you've got magma coming up, that all that could have turned to steam until another tsunami comes, and what's left is just salt. I mean, I don't fully understand all of it, but I haven't seen a good explanation in the secular world, and the fact that you got an evaporate, you got Luan salt, then they're saying it's dry land, and you got the Norphlet coming in, and then you got the Smackover, which is marine again, going rapidly from marine to dry land, Aeolian to marine. That never made a lot of sense, but saying that it's a tsunami coming in, the first water coming in, that gets evaporated, leaves salt, then some more comes in with organic material right on top, and then a little later there's another plot at the Wilcox time, and when we would expect to see lots of sand and these big turbidite sheet sands. It makes more sense than all this transgression and regression that I never really understood those, but this I can understand better. It better fits.
I think that applies for the east coast of South America or the west coast of Africa.
Yeah, I mean, it's pretty similar. You got an opening system. I don't know. Yeah, there's different salts there. There's certainly lots of evaporites. Any of these intercontinental openings, there's lots of evaporites in Mediterranean. It certainly could.
These models track along with secular models, just basically
Yes, yeah. But I don't see in the secular models, I don't see in the secular models any attempt to explain all the sediment over, because at those slow speeds, you're not going to generate the tsunamis. So yeah, the movement of the continents is the same, drift and all that. But you're not generating the amount of sediment, you know, explaining things like the Wilcox. You got these huge, thick, 1,000 feet thick sands that cover a lot of the deep water. If it's coming out of the rivers, which is what secular community is saying, why is it so laterally extensive? And you know, you'd expect, okay, maybe it's near one river, like the Mississippi, but it's all the way across. It makes much more sense with the tsunami coming in and then gradually spreading out and dropping out its sediment.
Know as well as I do, when you look at the seismic, you're going to see at least 40 sedimentary layer formations.
Yeah.
Where's it all coming from?
So I think, trying to think how many tsunamis are generated. It's in this model, I think he's got it. There's a very large number, and if each layer is associated with a tsunami, and then this is all modeled on the full 3D of the Earth, and so yeah, it's certainly possible.
Does this model explain, in your opinion, the significant fields that are right down in the center of the United States as well? Or you got the movement towards the
Yeah, I haven't taken it that far. That's a good question. You know, I've gotten into this fairly recently, and all my experiences in the Gulf of Mexico, so I focus there. But I imagine it could.
There are salt domes in Mississippi. Right?
Yeah.
That doesn't give you a problem.
No. There's other ways the salt can form. I was just looking for a way that the Luan salt could form. And I'm not sure it's right or anything, but I haven't, I've looked at some papers from experts, and they don't have they don't arrive at one conclusion either. They have lots of different potential ways. This just made sense to me, helps me explore.
Canadian Shield. Why is there no sedimentary rocks there?
So they believe that even though the waters went over there, it probably got eroded with later sediments. It was higher, so it had less speed when the water got there. And
it's a shield, it wasn't that high.
Well, but the other mountains hadn't been uplifted yet, so it was that were high areas. It's probably from the pre-existing topography.
The Rocky Mountains were formed yet?
They got formed fairly late.
Late by what? On your scale?
Now, I'm not a geologist. I'm,
They've got the Rocky Mountains, at least the last stage of it, around 60, 80 million years ago.
Mm-hmm. That's fairly late.
Well, that's earlier than, say, the Andes Mountains or the Himalayas.
Okay. Yeah, again, I'm not an expert at all of this. I'm just trying to say how I took this research and used it, and it's helped me, and trying to explain John's work.
The fact that the Canadian Shield, I'm talking basically the craton, without any sedimentary rocks there, suggests to me it was never submerged since the Paleozoic. Since pre-Cambrian.
Was it deposition there and then later removed?
Yeah, I believe that's
completely removed. Why would that happen?
erosion. Yeah. So
places like that.
So Tim Clary's work, I'm sure he could explain it better, but yeah, most of that he believes has got eroded off. There's a few remnant places that it's left, and he's got maps of each of these mega sequences.
It's done a heck of a job of erosion, but there's nothing left.
Well, but you had
Makes sense.
these speeds going up that had to be there. Anyway, I can't answer all these questions, but there are experts that can, and we can try to reach out to some of the experts before September. Yes?
Well, this is just a comment. You commented that in each of those pictures where you showed the places, everything was dry. But there was
Yeah.
always at least one tree, and in one picture there were 3 shrubs. And I thought that was remarkable. But the other thing I found truly remarkable is in 2018, 8 billion, not million, people live, and it reduced poverty with fossil fuels.
Yeah.
I think that's remarkable. We ought to
There's a very good correlation between fossil fuel use and poverty, or at least energy use.
less than $30 a day.
Yeah. Yeah, that's what so bothers me about you're saying we need renewable energy in Africa. They need fossil fuels, so they're heating wood and dung, and if they can get kerosene or things that much cleaner air, they need fossil fuels, and windmills and solar panels aren't going to provide all the energy they need. So yeah. Looks like we might have questions online.
So,
Go ahead.
do you have an opinion on climate change?
Yeah, well, I saw a really good documentary on it called Climate, the Cold Truth, and there's researchers at Harvard and Princeton, and they were talking, climate change appears to be very correlatable with sun activity, solar activity, and they go into that documentary explaining why, and very poor correlation with the CO2 levels. So I don't believe that any of it is caused by humans. It tracks remarkably with solar activity. And CO2, only 6% of the CO2 that's produced is produced by humans. Most of it's natural. And so to say that there's been a 1.5 degree temperature rise, I don't think it's even that great. Then humans have produced 0.1%. That's not going to change the weather at all. Humans have not caused climate change. It's just natural processes. Should we take questions from online?
Sure. Should be on the question and answer.
Looks like Pete and Brian have their hands raised.
Oh. Okay, the name, click on that, and then you get a list of them. Okay, that's the one I sent in earlier. So
See if there's a question. Okay.
there you go. Mhm.
Okay, so Pete asked, in the CPT model, what were the fountains of the Great Deep before they were all broken up on a single day? I think it could be, that could be what started the whole catastrophic plate tectonics that in the CPT model, that's the magma coming up, hitting the ocean, and then that creates those fountains. So I believe that could be how God started this whole process of the flood. Exactly what the fountains were, I don't know. Okay, another question. Does this imply all the mega sequence periods such as Jurassic, et cetera, occurred during and after the flood? So Tim Clary is the expert at this. Certainly the Jurassic is during the flood. It's near the peak of it, the peak of the water sea level rise. yeah, I think most creation scientists, and certainly myself, would call the Jurassic squarely during the flood. The only thing post-flood, in my opinion, is the Pleistocene and more recent. So the Jurassic would definitely be during the flood. So question about, see this or the previous presentation on HPT later. Yeah, I think Frank's going to try to get the video of this, as well as the hydroplate theory presentations online.
Oh, yes. Neither one of them up yet. Will be up quickly as I can do it. I'm recording things from YouTube, which is destroying everything, and put it on Vimeo where they don't add their own comments on opinions. So,
You're talking about.
we run problems, yes.
Were you talking about the presentation from last, two months ago, yes? That one that you're talking about, or?
2 months ago, hydroplate.
Yeah, starting with that one, and then this one, and then all the rest of them.
So, of course, that one's available now, everybody can see it.
It's available on the church website where it was done, yes. You can download it from that site. So it's available, it's just not on our site. I would like to have it on our site.
Another question was the name of the 3D model with the cells of the Earth like pixels. So John Baumgartner's 3D model is Mabul. That's M-A-B-B-U-L. It's the Hebrew word for deluge. And actually, after the DHCA presentation with John Baumgartner and Tim Clary, I talked to John and asked if there was any way I could help, and he was happy to do that. I actually got his Mabul program and ran it on my computer. I wasn't working at the time, and hoping to interpret all of the stuff that came out of it. And eventually I got back to work, so I understand his model and was able to make small changes and run it, but I don't know if I added a lot to it. But yeah, that model is Mabul.
Tell me about that comment, and you respond to it and tell me what part's right and wrong, or whatever. Generally, conventional view of geology is it's been going on at least billions of years, several billions actually, and everything is taken to be slow and gradual, uniformitarian type processes, and that characterizes the whole thing. What we're talking about here is radically different from the word go. We have an initial condition, the fathers we can imagine taking any observable processes and going back and past at the beginning of the flood. The flood is so violent, so changed geology so much that effectively we can't see by observational evidence anything before that. Mm-hmm. We can't even imagine what it might be. So what we're talking about, this Baumgartner model, catastrophic plate times, he was the originator of it, goes on so fast, so violently, that there is no way to go from one part of one to some corresponding part of the other. They're just so different that you cannot compare them in any way. You cannot compare from one to the other, from one part of one to some particular part of the other.
Yeah.
Okay. When you try to make that kind of comparison, and it is just the most natural thing for geologists to do, there must be someone one corresponds. No, there's not. They're completely different. So, we have to keep that in mind when you go from one well and try to critique the other. Often it doesn't make any sense from any aspect. Does that make sense to you?
Yeah. You know, my my feeling is, you know, lots of people have explored for oil and gas using the conventional models, millions of years old. And kind of recently, there's been a little less discoveries. And I think if we could, more people could embrace a different model, just try exploring on that method. Maybe you'd get some better results. And we need more oil. Part of it is because there's less investment going into drilling of wells, because it's kind of a regard.
Colleagues about what you believe?
Yeah.
You
On my farewell thing, I said I wanted to study more creation science and see how we could more effectively explore for oil and gas to many people.
You're a Schlumberger right now, right?
Yeah.
I used to work there. So you've already told them what you believe and what your strategy is?
No, I don't know that I have, but if questions come up, and I'd be happy to say that.
You're in the interpretation department there?
Yeah.
With Vivian Robinson?
Yeah, a little bit.
Back to the science. I understand what Frank's trying to say, but it takes speculation on that something like this would happen. Because I don't see where you can come up with all these tsunami scenarios. Scientifically, I don't understand how you can justify it.
Well, yeah, John does a better job than I do presenting his slides, but you know, as these things start, as the subduction starts, you creating greater stress. That's weakening the rock along the subduction zone. So then everything gets a little faster and a little faster, and it just builds. And then as it gets faster, you got creating more stress, so it's even weaker. And so he's modeled this physically, and indeed, because the rock is getting weaker, so allow it.
It's going on all the time. It's going on for a billion plus years.
No.
But the clock,
What proof do you have of that?
theological proof.
You can take it and saying the other model should look like that. And that is the one thing that does not work.
No, you're wrong again. You were there, right? No, you weren't there either for what you believe in. So don't use that argument. That's an invalid argument. But you weren't there, were you? That's, so you're changing on me. Let's keep it to science, right? I know the game you guys play.
Well,
there's a lot of evidence that
you get the
disputes millions of years.
Principle involved in the locking of plates, subducting, slipping.
Yeah.
In these models, that rise up motion is on nowhere of miles.
Yeah.
So that's one heck of a tsunami. And this is occurring in spots along all the subductions all along the North American, South American continent. Bam, 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 bam. Where the bands come at intervals of the bands come at intervals of an hour or so.
According to your model, what is the cause of the subduction?
Well, you have.
I hear him describe it.
The cause of the subduction is that.
No, he goes. He's avoided a number of my questions.
I'm not trying to avoid them. This is new to me a couple of years ago. I'm presenting someone else's work. Exactly what started it, I don't know that we know, but you have colder rock, that's going to be denser of the oceanic. It's going to sink beneath the continental crust. We see this happening today. Exactly. And it's what caused it to get fast and speed. That could be a God thing to create the flood. He had to have a method of creating it. And he could, you can't explain everything.
Because I thought the premise of this whole lecture was by science, not show. So that's why I'm asking questions dealing with science.
Right,
that's why we are all here.
Here's an answer. The subduction goes because the subducting basaltic seafloor being pressed against the mountain, up against the continent, commonly granite, so they're gonna go up. The basalt, cold, dense basalt is going to go down. Right?
Correct.
Right. All right. That's what we observe at a very slow rate. Now,
That's right.
right?
But we're talking about what is making all these big time tsunamis.
All right. Now, if this is going down much faster because we now recognize that the mantle weakens very rapidly.
Well, let's say I sort of disagree. with
That's
that.
something you don't know about because that work was done in France far after your textbook. Okay? So if you go research that, maybe you can learn something.
I am researching this all the time, Frank. And stop using the textbook. I use that one example about the Coconino just to show you that they were calling it Aeolian before you guys came up trying to change it to a water formation.
How do you get all these marine fossils in there? If it's Aeolian, you got all these massive intact fossils.
There's no marine fossils in the Coconino.
Well, maybe not Coconina, but nearby.
There are some footprints, but not.
There is all over the place.
There were some footprints, but there weren't any marine fossils.
You need to go do later research. There are ooids.
And I will send you more documentation. Once again, you'll either not read it or not comment to me.
I'll send, well, most of them.
Oh, really? So
Well, we've heard a lot from you. It looks like we have
I'll
another
send you the picture.
question. We have another question.
For his presentation.
Well, wait,
Yes.
we got one more question. Yeah, we can have more discussion about this next month, and
No, in heaven. I'm waiting for heaven. They got the answers.
Sorry for all the interruptions.
That's okay.
That's why I'm.
But you did well.
That's why I'm. Your whole.
I think that when Dr. Baumgartner presented, I don't know if you were in that.
Okay, well, thanks.
I think he said that in what Steve's
Well,
worried
you know,
about.
midnight, wait till it's going.
He said, he can do it, he can do anything.
Right. And it sounds like a cop-out, but we don't know what started it.
And it's okay, but
Yeah.
we don't know a whole bunch of things,
Yeah.
but we have faith. And so I thought he was on about, maybe he was on about how President Baumgartner started. And I think it seemed like he did say that he had to inject some temperature, maybe raise temperature.
I think that's right. I think it was a temperature differential that started it.
And so, and God could do that, or he could have done something else.